Okay, this is Unit 6B, looking at measures of variation. So in Unit 6A, we saw how to describe variation kind of qualitatively. We discussed it in a very broad sense. Didn't really get any numbers in there. We were just looking at the shape of the distribution and making some estimates or assumptions. Now we're going to turn to more quantitative measures for the variation. Okay, one simple way to look at variation is the idea, it's called a range. And the range is just defined as the difference between the highest and lowest values in a data set. So down here again, the range, you take, and you'll most likely hear me say max minus min, the biggest number or the highest value minus the lower number or the minimum, and that will give us the range of data, how far we spread out from top to bottom. And that gives you one idea of the variation. So that's a very simple and broad way to do it. Then what we can do is we can take that range and incorporate it into our median, and then we're also going to go from not just median but to quartiles, and this is what's called the 5-number summary, and this helps us see how spread out our data is. So instead of just looking, how far we are from bottom to top, this is going to give us 5 points along the way so that we can kind of visualize how spread out they are, from top to bottom and then in the middle as well. So this common approach involves what is called the quartiles, and that's just dividing your data into quarters. And so here's kind of how this works. So when we're finding the median, again, we kind of did it this route, and you can do this with StatCrunch with any technology as well. So there's 2, 3, 4, 5. So we get our median right there, 7.2. And then what we do is we cut the data sets in half. So then now we're going to look kind of down at this side, and we're going to cut down 1, 2, and we get that the lower quartile is 5.6, and you do the same on top to get the upper quartile is 8.5 on this big bank, this set of data we have here. Sometimes the lower, well, most of the times the lower quartile you'll see as Q1 or first quartile, Q3 for the upper quartile, and sometimes you'll see the median is, because since it's halfway, it's the second quartile, or Q2. So again, the lower quartile, which is the first quartile, just divides the bottom set in half, so it's the lowest fourth. Okay, the middle quartile, which is our median, Q2, it's right in the middle, and then our upper quartile is 3/4 of the way through. So our 5-number summary, then, is going to consist of the following 5 numbers. The lowest value, so the minimum, the lower quartile, the median, the upper quartile, and the highest value. So that 5-number summary is going to give us a good idea as to where, again, our lowest is, then 1/4 of the way, then half, then 3/4 of the way, and then the top. So it gives us a good idea of our spread or our variation. Okay, we can display the 5-number summary with what's called a box plot, sometimes called a box and whisker plot. And the way that is done, so you can see down below here, and hopefully at this point you have seen box and whisker plots before, but the way it's done is, I'll look at the big bank since it's more spread out. Okay, you plot your minimum point, then you plot quartile 1, then your median or your quartile 2, quartile 3, and then your maximum. So this little box right here is your quartile 1 through quartile 3. So that's 50% of your data right there. So that gives us a good idea of how spread out we are. The difference there, or how wide that box is, difference between quartile 3 and quartile 1, is also known as the interquartile range. That's used to help find outliers. But you can see, based off of these two, when we put these two box and whisker plots together, you can see that the big bank has much more variation than the top, because we're in this one we call the best bank. I mean, we're squoze down within a much shorter or much smaller amount of numbers, from 6.6 to 7.8 versus 4.1 all the way to 11.0. So it helps give you an idea as to how spread out we are, and it just visually gives you a very fast look. So here are your steps again to drawing that box and whisker plot. Okay, draw a number line that spans all the values in the data set. So that's what this information is right here. Okay, and then enclose the values from the lower to the upper quartile range in a box, and draw a vertical line through. So this vertical line is the median right here. Then add the whiskers going down to your lower quartile and up to your minimum and up to your maximum. So just in general here, again, what you do is you're first going to, you can draw your box, and this is where Q1 is at, and this is where Q3 is at, and then wherever your median is, say your median is right here, Q2, and then you can go down to say this is where your minimum is, and then maybe your maximum is clear up here. So they're not always perfectly symmetric, but we can see, again, just a quick overview of what this data looks like as far as spread. Okay, now the 5-number summary characterizes a data set's variation pretty well. It does a pretty good job, but statisticians and researchers and things, they like to, or they prefer to describe this variation with a single number. And the most commonly used digit or number for variation is what we call the standard deviation. And the standard deviation is just the measure of how far data values are spread around the mean of a set of data. Just kind of an average or the standard amount that we are away from the mean. So the bigger the standard deviation, the more spread out we are. The smaller the standard deviation, the less spread out we are. Okay, there's a little bit of information in there about a previous example of that you can find in your textbook, I should say, of comparing two different banks. But we're just going to look here. So the purpose again of the standard deviation is to represent an average of the sizes of the individual deviations, or how far one number is from the mean. Just it gives you the average of those, what we call deviations, without regard to their sign, so positive or negative. So I'm going to show you how to do this by hand so you can get an idea, but then we're going to be using StatCrunch or some other technology if you have that. So here are the steps. This can look and sound messy, but I'll give you an example here. Say we have let's say and I'm trying to make this simple for the calculation purpose. So say we have a data set that goes, I'll keep it in order, 3, 6, 7, 10, and 14. Say that's our data set right there. When you're trying to find the standard deviation, the first thing we need to do is we need to calculate the mean. So the mean, you would take 3 plus 6 plus 7 plus 10 plus 14 divided by, there's a total number of 5 there, so this gives you 8. So our mean is 8. Once we have found the mean, then what we need to do is we need to find the deviations for each data entry. So I'm going to create a little table here. So this is going to be our value. Well, that is not straight. Luckily, it will fix it for me. So our values are 3, 6, 7, 10, and 14. The first thing we're going to do is we're going to look at the individual, what we call deviations. And the deviation is how far we are from the mean. So you take your value, subtract the mean. So -5. So that means that we're -5 units, or 5 units to the left of the mean for the value of 3. And then for 6, you just take 6, subtract the mean, which is a -2. Then 7, subtract the mean, which is a -1. So all those are below the mean. And 10 subtract 8 is +2, so that's above the mean. 14 subtract 8 is a +6. So there's all of our deviations. Then, when we're finding our standard deviation, we need to take the deviations and we need to square all those. So we would take -5 squared, and all of these numbers should be positive. So that's -5 squared. -2 squared is a 4. -1 squared is a 1. And then 2 squared is a 4. And then 6 squared is a 36. Okay. Then we are going to find the sum of all those. So the sum is you're going to take and you're going to add them all up, so we get a sum of 70. Okay, now that we have the sum of the deviations squared, then the standard deviation is you take the square root of the deviation squared, so that's square root of 70, and you divide it by the number of entries minus 1. So we had 5 values or data entries minus 1. So the square root of 70 over 4, which is approximately 4.18. Okay, and that's our standard deviation for that data set. Okay. So when we look at the any number on average being 4.18 units away from the mean is going to be normal for this set of data. You'll find a lot. It turns out you'll find about 60 to 70% of your data fall between 4.18 units above and below the mean. So that's a look at our standard deviation and how you calculate it. The last little thing I want to say here, and then we're going to look at some more data sets, and we will use the we'll use technology. As you can see, the calculations of standard deviation was quite tedious by hand, and as you get much bigger data sets and as the means are much more complicated, they're not nice simple numbers, this gets messy in a hurry. But as you're trying to develop an understanding of the standard deviation, there is there's an approximation that's called the range rule of thumb. And that is, the standard deviation is approximately related to the range of the distribution by this formula. Standard deviation is approximately the range divided by 4. And then from there, you can actually find out some other information, knowing that the range is the highest minus the lowest. So then you can approximate the lowest and the highest values if you don't have that. But just using this concept, this process right here, the standard deviation is the range cut into fourths. It's just a range rule of thumb. It's an approximation. However, I will throw out there, it does not work well when the highest or the lowest values are outliers, when they're really big and far away from the mean. So just take that in consideration when you're looking at the range rule of thumb. So in the next video, we are going to cover examples with this range, with standard deviations and the 5-number summary and so forth.